Okay, for this last one, we're just going to crank it out. I'm going to do all of chapter 6 in one video. So here we go. All right, so this part 1 is just asking us to convert into moles. So how do you convert into moles is either using Avogadro's number, which is 6.02 times 10 to the 23rd. And what that is it's basically a unit of measurements just like the SI units like kilograms, milligrams, like any of that is. And it's just to this value. So basically 1 mole of atoms equals this many atoms. So when we go to do this first one, we start our railroad track method times 10 to the 18th atoms times 0.02 times 10 to the 23rd. I put that on the bottom because that's atoms, which cancels out from the atoms over here, and then that'd be in 1 mole. So you put 1 mole above the atoms because they're equal to each other. So yes, one second, let me grab my calculator. So I figured I'd do the calculation off camera. The answer is 2.59 times 10 to the negative 6th moles. So now let's do 15 grams of Ag. We start out with 15 grams of Ag on top, and now we go to our periodic table, which is where we find the molar mass, which basically tells us how many grams of silver there are in 1 mole. So let's go to silver over here, number 47. The value that my table has is 107.868. So I go 107.868 grams of Ag and 1 mole of Ag. So that gives me a result of 0.139 moles of Ag. So yeah, on to the next one, right? Okay, so we're using stoichiometry to determine the following. So we're given the reaction equation, and we're told that it's a precipitation reaction of pure AgCl, where your AgCl weighs 25 grams. So the first question is asking how many moles of NaCl reacted. So first off, our first step is to convert AgCl into moles so we can relate it to NaCl using the reaction. Because in the reaction we see for every 1 mole of AgCl that is produced, there is 1 mole of NaCl reacted. So 25 grams of AgCl. So now we got to find the molar mass of AgCl. With a quick Googling, I will return. Okay, we're back. All right. So the molar mass is 143.32 grams per 1 mole of AgCl. I looked that up on the internet. It'll be told to you on the exam probably. If not, you just add up all the components. So I just add silver's molar mass to chlorine's molar mass. That's basically what that is. So that tells us how many moles of AgCl we have. Now using the equation, we know that 1 mole of AgCl is produced from 1 mole of NaCl. So then that will give us our answer in moles of NaCl. So we can cancel out the grams of AgCl and the moles of AgCl, just to leave us with moles of NaCl. So basically the second part is asking the same thing. It wants us to convert to moles of AgCl and then relate it to sodium this time instead. So we already know how to convert it to moles, so we do 25 grams of AgCl times 143.32 grams of AgCl per 1 mole. And then it is 1 mole AgCl per 1 mole of Na. And so we get the same answer. Oh, I don't know why I drew the box. 0.174 moles Na. There we go. Okay, on to the next one. And this is the last one, I believe. So, for the following reaction, which we're given the reaction equation, we're going to react 100 grams of FeO3 with 3 moles of CO, and we're going to identify the limiting reagent. So in order to identify the limiting reagent, we have to convert everything into moles and then see how many units of the equation we can go through. So first off, I'm going to convert FeO3 into moles. So 100 grams of FeO3 into moles. Hey Google, what's the molar mass of FeO3?
Iron 3 oxide hydroxide has a molar mass of 106.867 grams per mole.
All right, thank you, Google. So that's the molar mass. So that's going to tell us the number of moles that we have of that. So let's go ahead and divide 100 divided by 106.867 equals 0.9357 moles. So that's how many moles of FeO3 we have, and then we have 3 moles of CO. So now we have to figure out how many total reactions we can carry out using just the coefficients. So what I do is I divide the number of moles by the amount of moles that are used to produce one set of products. So to produce one set of products, there's 1 mole of FeO3 used and 3 moles of CO2 or CO used. So then it's Fe3's moles divided by just 1. So it'd be 0.9357 over 1 equals 0.9357. So then for CO it would be 3 divided by 3, which gives us a total of 1. So now the limiting reagent is the one that is less. So the top one, or FeO3, is the one that's less. So that's the limiting reagent. Lr equals FeO3. And now in the second one, it asks us the moles of CO2 produced from that. So we know the moles of FeO3 that are going to be used in this reactants. So basically the limiting reagent tells us which one's going to run out first. So basically that's the amount of products that are going to be produced. So even though there is CO left over, it can't react with anything, so it won't produce products. So we use that to calculate the amount of products formed. So, and then we look at the ratio from FeO3 to CO2. On the left side, FeO3 has a coefficient of 1 in front of it, but CO2 has a coefficient of 3. So for every 1 mole FeO3, there are 3 moles CO2 produced. All right, so then that's just multiplied by 3. It gives us 2.81 moles of CO2. All right, and that's it. Good luck on your exam. This is all I can come up with that might be on it. So yeah. All right, bye-bye.